How does a VFD, or variable frequency drive, save energy and money? VFDs are basically a green energy savings product that matches the amount of work or load on a motor to the amount of energy it needs to power that amount of work. This reduces or eliminates the amount of excess energy being wasted. We use a lot of energy in this country, and most of that energy is used to move air and water around a building. About half the electricity in commercial buildings is just used to move air and water around, so a VFD is a big way to save energy there. If you look at a typical pump motor, 90% of its life cycle cost is the energy it consumes, and only 10% is the actual cost of the pump motor. A VFD can cut that in half. Most motors are oversized to deal with the worst-case scenario, the peak load. A VFD allows you to run that motor at the load it needs to be, instead of running it at peak load all of the time. Another benefit is its built-in soft start capability. These two things alone are going to give you savings, not only on energy, but also by extending the life of the motor. So, what is a VFD? Well, some of the different names that are used in the industry are a variable frequency drive, an adjustable frequency drive, a variable speed drive, or an adjustable speed drive. The technology has been around for quite a few years, but has only started to make some headway in HVAC and pumping applications in the last several years. The size and cost of electronics has made VFDs applicable to a wider range of motors and increased the opportunity for savings. All VFDs are going to take three-phase AC power and convert that three-phase power to DC power inside the drive and pulse it out in a simulated AC wave form to the motor. The motor still thinks it has AC power, but the DC power conversion now lets us control the speed of the motor without harming it. Now we are in control to save energy and money. The basic concept with the savings for VFDs is that your speed and your flow are more or less proportional, but the energy consumption is cubed. If you're running your motor at full speed or 60 Hertz, you don't have any savings, but any reduction pays the reduction cubed. But let's say you're able to take that oversized motor down to 90%. So at 90%, you're at 54 Hertz, or a 10% slowdown output from the VFD. Your savings is 27%. How's that? Well, if you cube 90%, or 0.9, by multiplying 0.9 times 0.9 times 0.9, the net result of that is 0.729. So now you're only using 72.9% of the energy you were using. The difference between that and 100% is your savings. So with a 10% reduction in speed, you save 27%. If you're at half speed or 30 Hertz, it's even more. Multiplying 0.5 times 0.5 times 0.5 is 0.125, so you're only using 12.5% of the electricity. Below this, you're really not going to get any more significant additional savings. What a variable frequency drive does is match the amount of energy your motor needs to the amount of work that's being done. This saves energy, a lot of energy. Think of an escalator. Let's say the motor is sized to carry a load of 50 people at its top speed of 120 feet per minute when there is a peak rush. But when there are only 4 people using the escalator, the motor is hardly loaded, and with a simple 10% reduction in speed that would be unnoticeable by the people, it would cut 27% of the energy consumed. Now that is what a VFD can do. Great applications are air handling units, industrial process cooling pumps, escalators, chilled water pumps, hot water circulation pumps, cooling tower fans, return air fans, chillers, air compressors, circulation and supply pumps, combustion blower fans, and injection molding machines. There's a lot of good applications, and you might even qualify to get a VFD with no investment and have it paid for out of your savings through our Energy Savings as a Service.